This is questions 1, 4 and 7 in exercise 8.6 in New Concise Project Maths 3A. We have to find, using calculus, the coordinates of the local minimum point of the curve y is equal to x squared minus 4x plus 3. The local minimum point on a curve like this is going to be a quadratic curve, is going to be the point on the curve where it turns from going down to going up. We can kind of see this in the diagram on the right. It will be like point B on the graph on the right here. And the way we do that is we're going to find dy dx and set that equal to 0. The reason for that is that at that exact point on a curve, on the local minimum point, and also the local maximum, but we won't have one of those on this curve, the rate of change of a tangent to the curve is equal to 0. It's parallel with the x-axis, which has no rate of change. So there's no slope on that. So what we're going to do for this is we're going to first find dy dx. In this case, that's going to equal to 2x minus 4. And then what we're going to do is we're going to set 2x minus 4 equal to 0. And we're going to solve that out for x. We're going to get 2x equals 4, which means x equals 2. And that just means that when x is 2, we're at our local minimum point on the curve. But we need to find the y value because we need to find the actual coordinates of it. So y is going to be equal to what we get when we substitute our x value back into our original function equation. So it's going to be 2 squared minus 4 times 2 plus 3. So we're going to get 4 minus 8 plus 3. 4 minus 8 is minus 4, and minus 4 plus 3 is minus 1. Like that. So we end up with the point 2 minus 1, which means the point 2 minus 1 is the lowest point that this curve, y equals x squared minus 4x plus 3, actually goes to. After that, it starts to go back up again. And let's look at question 4. In question 4, we're asked to find the coordinates of the local maximum point of a curve. It's a similar reasoning and process, only this time we're looking at the highest the graph is going to obtain instead of the lowest the graph is going to obtain. So we'll get dy dx to start with. So when we differentiate this, we're going to get minus 6 minus 2x. Now what we're going to do is we're going to set that equal to 0 because we need to find our local max. That's how we would go about doing this. So it's going to be minus 6 minus 2x equals 0, which means minus 2x is equal to 6. So x is equal to 6 over minus 2, which means x is equal to minus 3. And then from here we're going to use that to calculate out our y value by putting our x value back into our original function. So y is going to be equal to 7 minus 6 times minus 3 minus 3 squared. So that's going to be 7 plus 18 minus, and then minus 3 squared is 9. So we're going to get 25 minus 9, which is equal to 16, like that. Which means the coordinates of the local maximum point on this particular curve are going to be minus 3, 16, like that. Okay, now for our next one. For our next question, question 7, we're asked to find the coordinates of the local maximum and the local minimum points in this curve. So this particular curve is going to be a cubic curve. It's going to look like our diagram on the right. It's going to go up at some point and back down. Now it could be the other way around. It could be our local minimum point could be to the left or to the right, but either way it's going to look similar to our graph over here. So we're going to go through the same process as before. We're going to differentiate first. Let's say dy dx is equal to, and we're going to get 3x squared minus 6x minus 9. So we're going to set that equal to 0 to get our two x values for this. So 3x squared minus 6x minus 9 is equal to 0. Now we could factorize like this, but since all those numbers are divisible by 3, it'd be far easier to divide by 3 first. So that's x squared minus 2x minus 3 is equal to 0. So when we factorize that out, we're going to get x minus 3 times x plus 1, which means that x minus 3 is equal to 0, and x plus 1 is equal to 0. So what we've got here is x equals 3 and x equals minus 1. And now in order to get our corresponding y values out from that, we're going to substitute these two values back into our original function. So when x equals 3, y is equal to 3 cubed minus 3 times 3 squared minus 9 times 3 plus 4. So y is going to be equal to 27 minus 27 minus 27 plus 4. So y is going to be equal to, so 27 minus 27 is 0, and then minus 27 plus 4 is going to be equal to minus 23. So we get the point 3 minus 23. And then we're going to do the same thing when x is equal to minus 1. So when x equals minus 1, y is going to be equal to minus 1 cubed minus 3 times minus 1 minus 9 times minus 1. So that should be 3 times minus 1 squared. And then plus 4 on the end. Minus 1 cubed is minus 1. Minus 1 squared is 1 times minus 3 is going to be minus 3. Minus 9 times minus 1 is going to be plus 9. And then we have plus 4 on the end. 9 plus 4 is 13. 13 minus 3 is 10. Minus 1 is equal to 9. So we get the point minus 1, 9. Now there's two different ways we can go about determining whether we have a max or min point in each of these. The easiest of those is to compare the y values. So because our y value on our first point is far lower than our y value on our second point, the point 3 minus 23 is our min point, and the point minus 1, 9 is our max point. And that is that.